Well, g'day, this is Max here, Swan Valley Machine Shop, and this is Tips Blitz 19. So, what we're going to do, we'll give you a rundown on my indexing head here. This is a wide range indexing head, so you can do from 2 to 400,000 divisions. This is a 1980 model, it's made in Poland. It's a very good quality indexing head. Little tag on it. So the weight of this one is 104 kilograms. So this is a pretty weighty beast. She has a 10.5-inch centre height, and it can tilt negative 20 degrees or go right round the other way. So, being a wide range indexer, it's a bit of a different calculation to do the indexing, so we'll have a run through that. And also it's tailstock, it's a dual point tailstock, so you can adjust the knobs up and down, it will raise and lower the centres. Now this one can tilt. So it has a tilt here, plus or minus 10 degrees as well, so it's quite a sturdy tailstock. This size indexing head is more suited, once we get my big milling machine set up, this is the right size indexing head for that machine. So we'll run through the indexing calculations and then we'll put a piece in there and we'll cut some oddball divisions. So this head also has this plate here which has 20, 34 and 36 row of holes, so there's 3 other row of indexing holes here on this plate, and so you have this detent here which is adjustable up and down depending on which row of holes you're in here. Plus it has the features at the rear, so you can run a gear train through to the spindle for differential indexing, so you have an extension on there, and a banjo comes on here for the gears. Plus you can, with the banjo on here with a gear train, you can link this to your milling machine table for milling spirals, and also for, you can do lineal indexing with it, so you have to cut a graduated scale or for cutting a rack. So as you index around, the gear train will traverse the table along the desired amount. So this was actually, as far as I'm aware of, being Polish, it came as standard equipment on a Jaffo Jarrison Polish made milling machine. They're a very high quality bit of gear, so let's have a bit of a run through the calculation and we'll do some indexing. So okay, to work out the calculations to do the divisions on these wide range heads, we'll pick an oddball number. So we're just looking in the black book, Engineer's Black Book. Now they already have standard calculations worked out for a standard dividing head. So I'm looking for the lowest number of divisions that's not in here, and it comes up as 51 holes or 51 divisions, so we'll pick that one. So using our formula, so we'll have T equals 40 over 51. So what we do, we divide 40 by 51. 40 divided by 51 gives us 0.78431337. Now all the calculations on the wide range indexing you have to do in 6 decimal places. So we're going to have to round this number off. So we'll make it 784314. Now, this number then we break down to work out how many holes we index on our small and large plate. So this breaks down to 78 there, 43 over 10,000 there, and 14 over 10,000 there. So if we tackle this one first, so this is our large 100 hole plate, so we index 78 holes on our large plate. This one here is our small 100 hole plate, so we index 43 holes on our small plate. And this last one here, that's an error, an indexing error, 0.14. Now that's something that can't be evenly divided. So you can either choose to ignore it, because it's so small it's nothing. We'll show you an example of that later on, and just stick with these two numbers here. Or we can choose to keep it in the equation and we can reduce that error down to something that's indexable. So the way we go about that, we've got to reduce that to a number as close as we can to 1 over 10,000. So we pick a random number. We have our 0.14 that we use to multiply with. So if we multiply that, say, times 7, so 0.14 multiplied by 7, that will equal 0.98. 0.98 over 10,000. It's pretty close to 1. It's as close as you're ever going to get. So what we've got to remember now, this number here that we multiplied by, we use that to advance our error in different locations. So our dividing sequence becomes 78 divisions on the large 100 hole plate, 43 divisions on the small 100 hole plate. So every 7th division we go 44 holes on the small plate. So this 43 becomes a 44 every 7th index. So we go 78, 43, 6 times, then the 7th time we go 78, 44. Our next index, 78, 43 for the next 6 times, and then 78, 44. And that balances out the minute error that's in it. So we'll give you one more example. This other example is a different way you work the error out. And there's another, on the small indexing plate, there's another row of holes. It's a 54 row of holes. That's for angular indexing, but we'll cover that one at a later date. So say we want to do, maybe do 209 holes. T equals 40 over 209. So we go 40 divided by 209. Okay, that equals 0.191387.5. So we reduce that to 6 decimal places, so we round up the last number. So it'll be 191388. So it breaks down the same as before. We've got and 0.88 over 10,000. So our index becomes, that's the large plate, 19 holes on the large. That's the small plate, 13 holes on the small plate. And that's our error. Now our error, there's nothing, no whole number we can multiply 0.882 to bring it close to 1 over 10,000. So what we do, we increase our small amount of divisions by 1. So that will be 14. So what we have then, we subtract our 1914, which is taken from here. We subtract our original number up here, 0.191388 from that. So that equals 0.1914 minus 0.191388, and equals 0.000012. Now, we have to find a number we can multiply this by to bring it close to 1. So say we went 8 times 0.00012 times it by 8 equals 0.000096. Okay, now that is pretty close to 1 over 10,000. Okay, so how we then transfer that into our dividing calculation. So we've got our number here. Our new indexing sequence becomes 19 holes on our large 100 plate, 14 holes on our small plate, and remember the number 8. So we've got every 8th division we indexed 13 holes back to our original number on the small plate. And then we're back to 19 holes on the large plate, 7 divisions of 14 holes on the small plate, and then our 8th index we only index 13 on the small plate. So we'll get set up in the mill and we'll cut some oddball slots, shall we? Okay, we've got a bit of material in the chuck there. Oh, bronze ring, little end mill there as well, so we're just going to cut some slots around the OD of this part. So on our indexing here, we have our large sector arm here set for 78 spaces and a small sector arm set for 44 spaces, 44 holes. I mean, really though, we only are indexing 43, but remember every 7th index we have to go 44, so that's why that's set like that, 1 hole extra. So we'll crank the mill up, we'll cut some slots, see how we go. Okay, just to give a bit of an indication on how far the part actually rotates around when I'm indexing the smaller index plate, the very centre one. The diameter of this, or the radius of this, is 90 mil, or 3.5 inches, so looking at 180 mil diameter, or just, you know, around approximately 7 inches. So if I index around, I'll go 1 hole at a time. So I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 holes I've indexed, and it's moved the part 1/1000th of an inch. So that centre ring, with all the reduction, it's quite a fine division. So that's what's used to correct the error. When we correct the error, we're advancing an extra hole every, depending on the amount of teeth that you're cutting. In our case this time, every 7th tooth we were advancing 1 hole. So 1 hole, if I move 1 hole, the indicator needle doesn't even move, 2 holes, 3 holes, and we're gone. Probably 2/10, just over 2/10 on 3 holes. So that's how fine it is. So. Okay, now because of the high amount of divisions that we're indexing on the part, I mean this 51 divisions is only a relatively low number for what these dividing heads can do. If you combine the number of divisions with the number of the extra offset hole you have to do, like in this case, as we said before, every 7th division we had to advance 44 holes instead of 43 on this inner 100 hole circle. So the opportunities there, it's like a free pass for Mr. Bozo to come along, because it's very easy to miss a hole. You have to keep track of your divisions, so every 7th we had to advance 1 extra. So, and as we're seeing by the indicator, 1 hole, it doesn't even move the indicator, it's that small. 2 or 3 holes moves the indicator, a couple of tenths, that's it. So in a nutshell, these are a good thing for what they are, for the amount that they can index. But I think if you compare it to, say, differential indexing with the gear train at the back, I think there's less chance of Mr. Bozo coming along with the differential indexing setup with the gear train. But just with these, you just can't be distracted at all. The only time Mr. Bozo visited here was the camera ran out just as I was coming up to cut the last tooth. So, but no, they all came out nice and even. And, all come out right, 51 teeth, so we had a good result. So that's your wide range indexing head.